account for is that watch faces are actually the mirror image of the mathematical way we count rotations. So in mathematics, cosine and sine is designed, so if this is 1, that's 1, minus 1, and 1. Cosine and sine start from here and move this way. So that's the angle of cosine and sine. But watch faces, so this is math. What do watch faces do? They start up here and move this way. And that's what I got wrong. Fortunately, there's an easy fix for that, which is I just flip the two axes along the diagonal, and all that I have to do that is just say that the x takes on the sinusoid, and the y takes on the cosine. And all that's kind of stuff, just flip the axes. And so if I flip the axes now, when theta increases, it starts going down and around like that. So it's moving like a clock face. And it just makes it a little more intuitive so that we can think of it like a clock face. So the first thing I can do is I can put stations up here, right, to get our different stations. And then I need my x. X-axis is going to be all my columns. So I'm going to move this over here. Now you see it defaulted to an aggregate, sum, but I happen to know I have one record per day, per station. So I'm going to say that I want this to be a dimension. So it hasn't moved up into dimensions, it's not above the bar, but what it's doing is it's saying, for the sake of this view, pretend like this is a dimension. So it's taking each value one at a time. I'm going to move cumulative y's over. And I'm going to say, cumulative x. Sorry. My y's are my rows, my x-axis, and I'm going to change this to a dimension as well. So you can see it's already not bad. The style I can change back to a line. Now notice, look how dense it is, right? You can't see any of the spiral movement. It's just, what it's doing is it's just connecting every point to every point moving along this way, right? So why is it doing this? Because the plotting algorithm is going to say, oh, this is the first point, second point, third point, fourth point, fifth point, and it's just going up and down as it's moving along here. What we wanted to do is we wanted to follow the spiral, right? How do we do that? Well, there's this handy little icon, path. And what path needs is any field in there that has a unique ordering to it, like a rank, 1, 2, 3, 4, 5, 6, or like the day of the day. So if I drop the date in here, what it's gonna do is the path says connect the points according to the ordering of the field I put in there. So if I put in a time field in here, it's going to say connect the points in the order that time happens, as opposed to the order that is displayed. Right now the points are being connected as a line in the order that they're displayed, not in the order of time. So what I'm going to do is I'm going to drag time over the observed cumulative, and that's a date, and I'm going to drag it over to the path. I'm going to make it an exact and continuous. So we're going to make it exact date, and we've got our spirals. Not bad. We're getting there. So we've got our spirals going around. So that should be the end, and that should be the beginning. Let's just make sure. What is this? This is around 2012. And those are both 2012. Okay, so how is this? See, that's 1991, 429. This should be back in time, 3.3. Good. It's going in the correct direction. So time is advancing this way. You can see it had a few jumps in here where we had missing data, but basically it's moving clockwise, right? So if we look at here, we've got May 17th, May 25th, June 2nd, June 19th, and so on and so on. The next thing I can do is I can drop the color in. The question was coloring by year, so that the more recent years are brighter and the older years are darker. So again, we just take our time again, and I'm gonna drop it into color. And I'm gonna make year continuous. And now I'm gonna also edit the colors. I'm gonna use the Viridis, actually I'll use a different one than Viridis. I will use the plasma color scheme, and I will make it reversed so that the brighter stuff shows up in 2024, and I'll apply. And there we go. So now it's coloring by year, but we don't have the motion in there. The other thing I did is I made it a little bit, I thickened up the line a little bit to sort of make it show up a little better. All right, so let's see, how much do we have done? Oh, we're pretty good. The main thing we're missing is we haven't put the parameters on there, so we can just drag and drop the parameters and say, you know, go ahead, show the parameter control, and show the parameter control. We can just quickly make sure that the offset works nicely. So there, yeah, it spreads it out. Good, and we can change the date. Oh, I'm going to change this to a type in. So I'm going to change it to a type in, and I'm going to set this to August or June 1st. There we go. So that, okay, that all works just fine. We haven't broken anything there. Oh, is everyone doing okay for this? I'm not moving too fast?
Mr. Sheldon, how did we like change as when I'm dragging it is showing some of the cumulatives, no X and Y?
Oh, how did I change that?
Yeah.
So I said, make it a dimension.
Okay.
So what it's doing is it's pretending each value is uniquely, it's saying, oh, I'm gonna plot each value one at a time. I don't need an aggregate, I don't need a sum. I'm gonna plot each and every single value one at a time. So every one of those values that we've calculated, we're plotting a single point, and then, but because we're plotting each point individually, we then need to tell it specifically, oh, here's how you connect. Here's how you connect these together, right? You need to use the path to specify the order that the points get connected by a line. And the path is a box that's unique to the line. If I change this to something like shape, you see that goes away. I can then choose the shape, but that's it.
Okay, so I have a question in that
Yeah.
regard. For instance, we are trying to do a scattered plot, okay?
Yeah.
And then you know normally when you put in what's it? In your columns and row, it's automatically aggregates it, right?
Yes.
And then if you go to analysis to take off that aggregate, you're
Oh
able
yeah,
to do that.
yeah. So
Yeah, you won't be able to uncheck that.
no. Well, I can, but it doesn't make a difference.
No, I'm
Because-
talking about in that kind of situation.
Oh yes, yes. Let's do exactly that. So we'll just make sure our detail is we'll make sure our detail is by the station, and we'll drop our Y into here and our X into here. And station, and there we go. Year, and let's do day. All right, so this has done a scatter plot, and let's see what happens when we turn off the aggregate marks. Oh, and it did it automatically. Look at that. So if I turn this back on again, oh, it's not overriding that setting. So I wonder if I switch this back to measure. Okay, so here's some. if I turn off, nope, okay, so I'm gonna back that up. The answer is yes, you can definitely do it that way, right? So you can
Yeah,
turn
the
on and
reason-
off the aggregates.
The reason I'm asking is because in the
And that-
assignment you gave us, let
Yeah.
me put it that way. So I realized that I was not able to turn off that.
Oh, yeah.
Yeah.
'Cause
So it was really kind of, I don't know.
It must have had a field on there that it couldn't disaggregate, and it must have been, why would it prevent you from turning off the aggregates? There must have been a dependency on there of something that couldn't be set as a dimension. So, what would be a possibility? I'll have to think about why that definitely seems in the realm of plausibility that would happen. So I'm gonna delete this. I'm gonna these are both back to dimensions, good. Okay. So the only thing really left to do is to get the animation to work. This actually didn't turn out to be nearly as exhaustive as I was worried about. So to get the animation to work, this is the other little trick I use to get the animation to work. So if I put in observed years, and I jump these forward a year at a time, you can see it's only showing 1 year at a time, right? They're not overlapping on each other, which isn't helpful, right? So that's the first thing. The other thing is the other thing that you notice is that it's displaying whole lines at a time, right? That's actually making things run faster, so that's pretty good. So the first thing is to get the lines to show up on top of each other. So you need to click Show History, and don't include any of the trails. We don't need any fades or anything like that. So we'll just Show History, and it's still not working. So this is where that link to that deep bit of obscura, that knowledge base, it was some help desk professional at Salesforce responding to a question. And this deep bit of obscura is you go into Format, Animations, and you turn it on and you turn it back off again, and then should work. Nope.
What about if we will turn on the trails?
No, it's reset all sheets, turn it off, work for. It's still not showing the history. So it's showing the history here. Yep. Okay, that's fine. Basically, what that advice came down to was turn it on, show history, turn off. Yikes. Okay. Oh, sorry. That's what I left off. Show history, and you have to show all. Now, if I roll this forward, you can see it's showing the whole history. But it's kind of jumpy, right? It's adding whole years at a time. So the last little trick I did in this to make it look a little smoother, but still perform well, is I went at the level of month. So I'm adding 1 month at a time, and that way it still runs smoothly. But there's just a little bit more detail as I move the lines forwards. If I was to go to something like exact date, this would be terrible. You just wouldn't be able to, like, you can see that I can barely even move that slider forward. There's just a huge delay there. So I actually found week number worked pretty well as well. So you just have to play around with the scale. So the week number is actually working pretty well. It's a little more jumpy than going at months at a time. But certainly, and can I set this to continuous, or is it going to, no, it doesn't like that. The only little thing with this, with the way it's jumping, is if you look, you can just barely make out the breaks of each month, and that's where doing it, or each week. That's where doing it a month at a time. You get a nice bit with. It looks fairly continuous. Right. You can't really. You can see a couple. You can see a couple points where it's breaking on the month. Right there, it decided to break on the month, and you can see there's little divots there. But that's just tiny little artifacts. So that's it. That's how to get a spiral graph up and going in Tableau. So the heart of the spiral graph is the most important bit is creating that angle, right? You have to decide what your angle is going to be, and in this case, our angle is simply how much of the year we've been through as time is progressing, and so that's where this divide by 365.25 comes from. And then I had to multiply by 2 pi so that cosine and sine worked out properly. Any more questions about creating a spiral graph in Tableau? No? So the next thing I want to do is I want to create a graph similar to this one, but I'm going to have time on the x-axis, and I'm going to plot out each year's cumulative snow. And then what I want to know is how far those are deviating from the interquartile range. So let's start with rename as annual cumulative snow. Right? And I'll do, my rows will be my stations. And we'll just start with time, and we'll do it continuous, and we'll make it the exact date. And then the next thing I need to do is just put my actual snow water equivalent amount in here. And I can make that a dimension as well. Or I can, yeah. And let's make this a line. Now, we can see time going on year over year, but what I want to do is I want to get a sense of how these years compare to each other and how they compare to their interquartile range. So what I actually want is I want to line these up according to the progress of the year, and I want to start on August 1st, and I want to end on July 31st. So I need to come up with a different way of displaying time. So let's just try to take a particular part of time. So we could take, for example, let's see. I want to get all right. Okay, so what I want is I want all the days to line up on each other. So if I take, for example, the where is my week number? That's the I thought there was a day of the year. All right, there's no day of the year conservation. So what I'm going to do is I'm going to create a calculated field, and I'm going to call it day of season. And what I want is I want to grab a date part. Date part. And I should be able to the observation date or the timestamp. Timestamp to cumulative. Let's see if this works. Give a dimension. No, it's still, that's still just the day of the month. I'm going to make this, I'm going to convert it to dimension. Now what we're going to do is, what I want to do is calculate how many days past August 1st of the season it belongs to. So the first thing I need to do is I need to figure out, you know, what season it belongs to, like and I want to set that to August 1st. So it's a little bit complicated to think of, but let's kind of work through this. So if we have, let's think of 2 years here. So we've got January 1st, and then January 1st again, and I've got August 1st, and August 1st again. So I want all of these, I want to be taking the amount of time from here regardless of the date. So what I need to do is I need to, let me think of this. If I truncate everything to the start of the year minus a day, that gives me the year, and then I add 8 months. That puts me back to there, and that gives me the starting point, so I can take the date diff that way. Okay. So we're going to take the date difference, and we need it, and I want the number of days, and the start date is going to be what I'm going to truncate, and the end date, the end date is my actual observation, observed, where is that? Oh yeah, observed cumulative. Now the start date is I have to take that observed cumulative and I have to figure out what the August 1st is. So, let me think about this. If I have August, so this will go to, now if I have this sitting on the 30th, and I round up to the beginning of the year, the 25 and minus, all of these other ones will go to the beginning of the year. Okay, just need to make sure I get this right. So the first thing I need to do is I need to date truncate, and I want to truncate to the beginning of the year. And it's going to be that observed cumulative date. So let's just see what this does first. Okay, and I'm going to So right now, the way this works, it, oh, I'm gonna, yes, it did work. Okay, so I'm gonna change this to a continuous. Change it here as well. And change this to convert. Undo. I'm gonna make sure this is always continuous. All right, so what I have here is the day of the season. What I have here is the day of the season, and if I put my extra level of detail as the year. So what's going on here? Well, this is January 1st is my 0 date, and then you can see our snow is accumulating, and then it drops off, and just after, about 2/3 of the way through the year. So if we pick August 1st, we can reset the season again. So what's going on here is this is January 1st, this is December 30th here, and we've simply counted the number of days in between. But we actually want to rotate that so that we want to rotate that, not rotate it, but we want to shift it so that 0 is about here, right? And 365 is back here, so we get one whole single lump in there as a single season.
Show the formula, sir.
Just show the what?
We can put, day of
Do
season.
you want to?
Day of season, yeah. And right now, this is actually, this is, edit, I'm gonna call this is actually day of year. So how is this getting the day of the year? So this is my end date, right? So that's the end here. The start is I take the end date and I say truncate to the beginning of the year.
Okay.
This date truncate takes whatever date you have and sends it back to January 1st of the year it belongs. So that difference here, the start is January 1st. This start date is January 1st of this year, and then that date is that date. So the difference is the number of days from January 1st until
Means from the start of data to the end of data.
in the year, just in the
year,
in
that
the
time.
year. Yeah, in that year. So the only thing left to do is to push this forward by an appropriate amount, so that these all line up properly. And the easiest way to do that is to add the 200 and take modulo 365 would be one way to do it. Another way is to actually specify when our season starts. What is the start of the season? So let's create a. I'm going to create a new field called start of season. I'm going to create a calculated field called season start. And what we want is we want to return the preceding August 1st of the date. What's the error? Oh, that's it. Return, so I'm going to take the observation date. And what we need to do is figure out how to use our date fields to, we need to figure out how to use our date fields to reset this date. So what we want to do is, let me think about this. If I truncate the month and then subtract 8 from that, do an 8-month date difference. Alright, so let me just think through this carefully. Sorry, so I need to, if I have after August 1st, I want to go to this year. If I have before August 1st, I want to go to that year. So one way to do that is to so first off, I have to truncate all of my dates to the start of their month, and then so that gives me the start of the month, and then I can truncate. If I truncate to the start of it, I don't double truncate. So we start by truncating to the start of the month. That's the first thing we do. We date truncate to the date part is the month. So this is going to go to the first of the month. This creates a new date that's on the first of the month. One way to do this is if so if I do that, and then, oh wait, there are 8 months in there. So if I subtract 8 months and then truncate, take the date, subtract 8 months, and then round off to the year. So that's so simple to say. So the innermost term is date diff. So I'm going to subtract months. So we have month. Oh, no. Sorry, it's not date diff. It's date. Where date add. There we go. So the date part is month. What I want to do is I want to subtract 8 months from that. Okay? So that August, let me think about this, 7 months. 7 months. If I subtract 7 months from August, August is 8, that goes to January, right? So subtract, and then the date is the observed date, done. So that's the first bit. The next bit is, I want to surround that in a date truncate. Date truncate is I'm going to truncate that date, but I'm going to truncate it to the start of the year. Like this. There we go. And what we'll do is we'll just make a quick table to make sure these are working properly. And I'm just formatting out the code nicely so I can read through it. All right, so I'm just going to say this is just going to say send August to the preceding January. And I'll fix the spelling later. All right.
What about observed date, observed cumulative?
That's our actual date of our observation, right? So we're taking our actual date of observation and we're subtracting 7 months from it. So August goes to January.
Do we need to give the end for this, like from where to where?
No, no. So we're taking the actual date, we're subtracting 7 months from it, and that way August goes to January. And then what we're doing is we're saying truncate to the beginning of the year. And so what's going to happen is if you're in September and you, let me think of this, did I get that right? If I'm in August, I need to subtract 8 because I have to go to December.
Yeah.
Yes, please.
Observed date, like.
Yeah.
I have
To
a
the-
question.
Yeah.
Not all the observed dates are in August, right? Some are
No.
in February, some are in.
That's right. So the idea is we take any month, August or before, and it gets sent into the preceding year.
So,
So-
if it's July and if you're subtracting 7, it'll go to December of the previous year.
Yeah, it has to be 8, because I want August 1st, let me think about this. If I take August 1st and I subtract it, it'll go to December 1st, right?
Yeah.
No, and do I want August 1st to go? I want August 1st to be the new season, so it does have to be 7, that's right. So August 1st will go to January, July will go to December. So when I truncate December to the year, it'll go to the previous year. So what's happening is all the months between January and August are getting assigned to the previous year.
Yeah.
And all the months from August until December stay in that current year. And what that does is it turns this into a single season. So let's just take a look at, let's do a quick table of some dates. We'll just make a bunch of rows of dates, and I'll say, give it all the way to the full day. I don't want it like that. I want it discrete. And let's just take the start of season start and put it in there as a full day. Come on. No. I'm gonna make it discrete day. All right. So see, October 15th of 1983 goes to January 1st of 1983, which is fine. If we go down, let's find, so where does the switchover happen? So, let me see, actually, I'll go down quite a bit further until we have, there we go. So, July 31st, 2010 goes into the 2009 year, which is what we want. August 1st goes into the current year. And August 1st through to September is in the current year, through to October, through to November, and December is in the current year. And then the next January, even though it's January 2011, goes to 2010. That is exactly what we want, because now I can change day of year to day of season. Edit. So we're gonna say day of year, I'm gonna change this to day of season. And my start date is gonna be my season start. And I'm gonna say apply, okay. And now this is, oh, how is that 200 to 550? Okay, sure, yeah, I'll go with that for now. We can just subtract 200 from that later on. But what's happening is, now we have a complete cycle of a single season on the graph, right? Each line is a single season's worth of snow, and we've got the complete cycle there available. In fact, I could take start of season, I could take season start, add it to the pages, and move these folks and show history and show all the history. And go back up here. And what we can do, and I'll get rid of the fade as well. We can watch the seasons accumulate year after year. There we go. So the next thing I want to do is I want to put in the IQR ranges in here, right? So I want the bars for the min, the max, or not the min and max, but the 25 median and 75% quartiles. And the reason why we choose quartiles in this situation is because year to year, these may be actually drawing from different distributions because of global warming. Our actual physics of the snowpack is changing year over year, so it's not stable. if these were guaranteed to be stable, if we didn't have global warming, then you could use standard deviation and mean, and that would be fine. But standard deviation and mean generally imply a stability of sampling, right? You're sampling from a stable distribution. The IQR doesn't imply any sort of stability in sampling. So we're going to use the interquartile range, and I'm going to also use this as an opportunity to demonstrate Gantt charts, because I'm going to underlay a Gantt chart underneath, so that we use the Gantt chart to create the IQR boxes. Pretty good, actually. All right, so let's do our very first table level of detail calculation. So I'm going to do it on the snow water equivalent, create a calculated field, and so what I want is for each station and day of season, day from season start and day from season start. Oh, that's what I forgot to do. Okay. For each station and day from season